Boys and girls, it is good to be with you today. In this session, you'll be with me. I am Chong Yipei from SMK Pusat Bandar Puchong 1, Selangor. Are you ready with your notebook and stationery? Let's get started. The first unit we are going to learn about is force. At the end of the lesson, you will be able to elaborate and communicate about force. Explain that force has magnitude, direction, and point of application. Measure force in SI units using the spring balance. You'll also be able to elaborate and communicate about the effects of force. Classify and solve problems on levers based on the position of fulcrum, load, and effort. Elaborate and communicate about gas pressure on the kinetic theory of gas. Explain and communicate about the existence of atmospheric pressure and effects of altitude on the magnitude of pressure. Explain the effects of depth on liquid pressure. Let us watch this video on the tug of war championship between Malaysia and Philippines.
ตอนนี้ระหว่างทีมที่3ครับเราฟิลิปปินส์กับมาเลเซียนะครับทีนี้เสร็จแล้วนะครับตอนนี้เป็นผู้ประกาศเรียบร้อยลงไปเป็นผู้ตัดสินนะครับทีมสียาเชียร์หน่อยครับโอ้ทีมที่3นะครับทีมเชียร์ก็มาเลเซียคอยขยับฟิลิปปินส์เอาแล้วไปแล้วฟิลิปปินส์ว่าไง
Boys and girls, do you know how the video is related to the topic today? Yes, this sports championship uses force that we are going to discuss today. Okay, let us investigate more in this lesson. Let us define the meaning of force. Force is a pull or a push upon an object. From the video you have just watched, which type of force is used? Yes, it uses the pulling force. This is another type of exercise that everyone should know. Push-up. It uses the pushing force. Boys and girls, now let us learn about the types of forces. There are 6 types of forces that we will learn about: gravitational force, weight, normal force, frictional force, elastic force, and buoyant force. Let us understand each force together. Gravitational force points towards the center of Earth. It will cause all objects that are thrown outwards to fall back to Earth. You know why this book fell on the table? Yes, it is because of gravitational force. This is weight, another type of force. It is a gravitational force acting on an object. Boys and girls, please look at the book in my hand. Do you know which type of force exists? Yes, there are two types of forces that exist here. One is weight that we have discussed. Another force is the normal force that is produced when an object is in contact with the surface. Now, I want you to watch the action that I'm doing now. Do you know which type of force exists here? Yes, it is the frictional force that resists movement between two contact surfaces. So, here, the contact surfaces are the table and the book cover. Please look at this diagram. The direction of frictional force is always opposite from the direction of motion. Boys and girls, please look at my action now. Do you know which type of force exists now? Yes, it is an elastic force that exists when a material is stressed or compressed. Now, everyone please look at this diagram. This is buoyant force. Buoyant force is the thrust force acting on an object that is floating on the surface of a fluid. Now, let us discuss the characteristics of force. Force is a vector quantity. Boys and girls, what is a vector quantity? It means that force has magnitude and direction. And what is magnitude? Magnitude is the quantity or value of a measurement. We can measure the force and know the value. Direction is the path or course of a given movement or moving body. It shows the point toward or from which an object is moving. Now, boys and girls, this diagram shows a pushing force with a magnitude of 10 Newton acting on a box. The direction of the force is as shown by the arrow, and the point of application of the force is the hand that exerts the pushing force onto the box. Boys and girls, do you know how force is measured? Have you seen this device before? Yes, it is a spring balance. It is used for measuring force. After measuring the force, we had to put the unit for it. Do you know what the SI unit of force is? Yes, it is Newton. Please take note, everyone, that all measurements must have a unit. Without wasting time, let us discuss the effect of force. Here, we are going to discuss the effect of force, levers, and pressure. First, let us discuss the effect of force. As you know, force cannot be seen, but its effects can be felt. When a force acts on an object, it can change the shape, size, and motion of the object. As you can see from my action, force can move a stationary object. When a stationary object is pushed, the object moves. When force is applied on the opposite direction, the object will stop moving. So, force can stop a moving object. Force can also change the speed of an object that is in motion, as you can see in this diagram. Now, let's look at my action. Force can change the direction of motion of an object. Boys and girls, please look at my action now. Do you know what is the effect of force on this object? Yes, force can change the shape and size of an object. Now, let us discuss levers. This is a lever. In this diagram, you can see the parts of the lever. The parts of the lever include the efforts, fulcrum, and loads. The lever is a simple machine. It can allow us to do work easily, and it can also allow us to use minimal force to do work. Now, let us discuss the classification of levers. This is a first-class lever. The fulcrum is between load and effort. And these are examples of the first-class lever: a pair of pliers, a can opener, and a pair of scissors. If you see that the load is in between the fulcrum and effort, then this is a second-class lever. From this diagram, we can notice that the load is in between the fulcrum and effort. These are examples of the second-class lever: the wheelbarrow and the nut cracker. This is the last type of lever, the third-class lever. In a third-class lever, the effort is in between the fulcrum and the load. Attention, boys and girls. For classification of the lever, just remember the part that is in the middle. These are some examples of third-class levers. They are the ice tongs and the fishing rod. Now, everyone, let us discuss the principle of moments of levers. Please look at this diagram and remember the formula. Load times distance of load from fulcrum equal to effort times distance of effort from fulcrum. Now, let us do a simple mathematical question. Boys and girls, please get ready with your calculator. Two children, Jiaying and Weihong are sitting on a seesaw. What is the distance that Jiaying has to sit from the fulcrum so that the seesaw is balanced? From this diagram, we can see very clearly that Jiaying's weight is 200 Newton and Weihong's weight is 300 Newton. Weihong's distance to the fulcrum is 2 meters. So, to make the seesaw balance, we have to get Jiaying's distance to the fulcrum D. So, we just need to put the numbers in the formula. That is 200 Newton times D equal to 300 Newtons times 2 meters. Please follow the steps as shown here. Lastly, use your calculator to get the answer. Now, D equal to 3 meters. This means that Jiaying has to sit 3 meters away from the fulcrum to make the seesaw balance. Boys and girls, lastly, let us take a look at pressure. Please look at the two diagrams that I am going to show you. This is the first diagram. Press a thumbtack into a plank. Can you imagine what will happen after this? Yes, that's correct. There will be a hole in the plank. This is the second diagram. Press a coin into a plank. But you cannot press a coin into a plank, even though the same force is applied. Do you know why? This is the answer. The effects of force acting on a surface depend on the surface area on which the force is applied. Force applied on a smaller surface area will result in a larger pressure. Conversely, the same force applied on a larger surface area will result in a smaller pressure. So, the formula for pressure is force per surface area. The SI unit for pressure is Pascal. Now, let us discuss gas pressure. Please look at this diagram. Surely, you would have played with balloons when you were young. Do you know why balloons expand when you blow them up? Why do the balloons deflate when the air inside them is released? We can get the answer from the kinetic theory of gas, which says that air molecules constantly move about freely and collide with the walls of their container. The frequency of collision between the air molecules and the walls of the container will produce a force that pushes against the walls. This force is called air pressure. Boys and girls, please look at this diagram. This can make you understand better. The gas particles are moving faster and randomly in the container. It hits the container wall then bounces back. So, the gas pressure exists when the gas particles hit the container's wall. There are two factors that affect air pressure. The first factor is volume. When a closed container is compressed, the volume in the container is reduced. This causes the air particles to collide more frequently with the walls of the container, and so the air pressure in the container increases. The second factor is temperature. When the air temperature in a closed container increases, the air particles move faster. This causes the air particles to collide with the walls of the container more frequently and with a greater force. Therefore, the air pressure in the container increases. Boys and girls, I'm sure you would have drunk a packet drink, like what this girl in the picture is drinking from. When the drink is sucked out of the packet drink, the packet will compress as shown in the picture. Can you tell me what causes the packet to compress? Yes, it is caused by the action of atmospheric pressure. When the drink is sucked out, there will be a partial vacuum inside the packet, and so the air pressure inside decreases. When this happens, the higher air pressure outside the packet will press onto the packet and compress it. This is the definition of atmospheric pressure. It is a pressure exerted by the atmosphere on the surface of Earth and all objects on Earth. Did you know that the atmospheric pressure depends on altitude? Atmospheric pressure decreases as altitude increases. This is due to gravitational attraction. Air molecules closer to the surface of Earth are pulled together by gravitational attraction, causing a rise in pressure. At higher altitudes, air molecules are less affected by gravitational attraction, so air becomes less heavy and expands easily. This causes a low atmospheric pressure at high altitudes. On the other hand, the pressure in liquid is different compared to the pressure in air. Liquid pressure increases when the depth of liquid increases. As you can see here, the water spouting from the bottom of the container exerts the furthest distance. This is because the pressure increases with the depth of water. Boys and girls, let's recall what you have learned by answering some questions. Are you ready? Question 1. What is the type of force used based on the given statement below? The force which pulls all objects towards the center of Earth. Please think carefully. You are correct. The answer is C. Gravitational force. Question 2. Which is an example of a second-class lever? Very good. The answer is D. A wheelbarrow. Now, we have come to the last question. What happens to the air pressure when the altitude is higher? Excellent! The answer is B. The air pressure decreases. Well, boys and girls, we have come to the end of our lesson for today. You are now able to elaborate and communicate about force. Explain that force has magnitude, direction, and points of application. Measure force in SI units using the spring balance. You have also now able to elaborate and communicate about the effects of force. Classify and solve problems on levers based on the position of fulcrum, load, and effort. Elaborate and communicate about gas pressure based on the kinetic theory of gas. Explain and communicate about the existence of atmospheric pressure and the effects of altitude on a magnitude of pressure. And explain the effects of depth on liquid pressure. Remember, boys and girls, besides studying, please help your parents to do the house chores too. Everything around us is science. We need to observe and think scientifically to improve our science knowledge. Thank you, and until we meet again, bye-bye!